With our continuous improvements, we also wanted to talk about a few myths and truths about battery technology. The first myth I want to cover is the difference between ground fault and thermal runaway. Thermal runaway is an exothermic chemical reaction that happens inside of the battery chemistry. It's typically started by a short circuit or a heating event, either inside the battery or external to the battery, that results in an exothermic increase in temperature. This is common in lithium chemistries and can result in a 200 degrees C rise in temperature instantaneously. That, in essence, is thermal runaway. Some battery products are incapable of thermal runaway because they do not exhibit this exothermic reaction, and Nickel-Zinc is one of those. The UL 9540A testing shows that in all of the different test cases, there is not an exothermic release of energy with the Nickel-Zinc product, and it is incapable of thermal runaway. Ground fault is different. Ground fault can happen to any battery product and any chemistry on the market, and it's a result of an unintended connection between an electrochemical potential and ground. This can be misuse, misconnection, or some other scenario, but when the battery is connected to the ground unintentionally, it will discharge all of its energy until the energy out of the battery is gone. That will result in heating of the battery, again with any of the battery chemistries or products on the market, and this can be mitigated through electrical system design and other safety features. Different from thermal runaway in that thermal runaway is the exothermic release of chemical potential. So, the myth, all battery products can go into thermal runaway, or ground fault and thermal runaway are the same. The truth is they're very different, and thermal runaway is only common in specific volatile chemistries, not nickel-zinc. And ground fault can be mitigated with system design and is possible for any battery products on the market. Another myth, BMS or battery monitoring system alarms are a nuisance. I know batteries used to be in a room tucked far, far away that someone would look at 4 times a year and give you a paper report. Those days are gone. Modern chemistries like nickel-zinc provide real intelligence, real analytics, and real alarms. Our ZincFive BMS is the perfect culmination of this. We give advanced alarming, advanced controls, and we give the operator a user interface to take advantage of all of this data. So use it. Look at it regularly. Train your operations folks. BMS alarms are not a nuisance. They're useful information for your operations team to maintain uptime. Another myth I want to talk about is that nickel-zinc batteries take a long time to recharge. This is not true. We are equivalent to other technologies on the market. We just do it slightly different. So with nickel-zinc batteries, we wait until the battery has cooled below 40 C to initiate a recharge. Once that recharge is initiated, we charge at rates that are 2 or 3 times as fast as competing technologies. Other products, they may charge immediately, but they require really small amounts of current to not increase the cell temperature too fast. That's not usable capacity. So from a 0% battery to a 100% full battery, something that can give you a battery backup discharge, nickel-zinc is equivalent or faster in certain scenarios. The other benefit of nickel-zinc chemistry is we can deliver max power and max current at very low SOCs. So even if you've just had a battery discharge and the battery has drained completely, there is still usable energy and full power in that battery, meaning we do not need to initiate a recharge to give you another discharge. So, the myth is that nickel-zinc batteries take a long time to recharge. The truth is, we do it slightly different, but from 0 to 100%, we are faster or equal to other technologies on the market. The last myth I want to talk about today is that nickel-zinc batteries are expensive. Battery cabinet per battery cabinet, there is a cost delta. But when you step back and look at the UPS as a system, we typically require half the quantity of cabinets versus competing technologies. That means there's footprint savings, fewer cabinets being purchased, which improves that cost delta immediately. Coupled with the safety benefits, no fire suppression, burn-rated walls, other codes, standards, and permitting issues with lithium and other technologies mean that the total cost of ownership at the system level for nickel-zinc is significantly less. So the myth, nickel-zinc batteries are expensive. The truth is, if you step back and look at the data center as a whole, that total cost of ownership with nickel-zinc batteries are significantly lower than lithium and other technologies. So at the end of the day, our goal is to educate on nickel-zinc, and hopefully today we've talked about some truths and we've dispelled some of these myths around our chemistry and how we're different from other technologies on the market.